Awesome. There we go. Now I've got audio. We are trying a new setup here today. Let's see how this works. Alright, let's see if we are getting anything on the stream. It looks like Jan is here. How do you do, sir? Very good. Very good. I'm trying to see if I can get the streaming working so we can get a good recording today. Just coming to you from from a client office today, so it's a bit of a different setup. So I'm trying to do everything on my Mac, and it looks like it's, well, at the very least we can hit that record button right there. So yeah, if we don't get this streaming live, then at the very least I can upload.
No, I think communication-wise, like, well, maybe I should.
Okay. All right. Well, so yeah, how have you been the past couple of weeks? Mm-hmm. Aha, yes. Mm-hmm. Yeah, I've actually been doing a lot of thinking about that algorithm, and I think I've got a modification to it that actually makes things a lot cleaner, but also solves more problems. So yeah, I wouldn't be too concerned about things not quite gelling, because there's a more general and more understandable way of thinking about it. Yes, yes. Let me see if I can find where was I doing that work. It wasn't yet a presentation. I'm trying to open up a PowerPoint deck that I realize now that I was doing on a different machine, and I am not certain where I saved it. But yeah, I'm not seeing it in my recent list there. So okay, well, we can kind of just talk through what it is that I have discovered. So in the book, I'm talking about how you build a pipeline out of individual steps. So a step follows an edge of the graph, either in the direction of the successor or the direction of the predecessor. And so the step identifies what is the role of that edge, and then what is the target type. Is that going to lead down to a successor of a certain type? And then another type of step within the pipeline was a condition and or a filter. I can't remember which of the two words I used, but filter. Yeah. So it only allows through those things for which the sub pipeline produces interesting results. Produces facts or not. So what I discovered is that, and then from there I started doing some optimization. So I said, okay, if you have just seen this fact, then we know that it doesn't have any successors yet. So if the very next step is to follow a successor path, then you know it's not going to lead anywhere. So just ignore it. Or if the way back to the initial, to the starting point. What's that? Right. Yes. So you would you basically end up only starting from places that are in the valley. So if you if the next step forward is a successor, you can skip that. If the next step backward is a successor, you can skip that. So things that are on the climbing the hill on either side, you can ignore. But the things that are in the valleys are the things that you keep. And what I observed when translating the queries into LINQ for Jinaga.net is that those are exactly the points in the query that you have to give names to. And so from there, I basically recognized that the optimization was already built in if I assume that you only talk about named points within the graph. So I can bring up Visual Studio Code and we can talk about something a bit more specific. So let's see. Yeah. All right. I will share this. Oh, I have to drop and rejoin in order to do a screen share. So I will be right back. All right. Okay, that didn't take too long. Awesome. All right. So there's the infinite screen. Okay. And then go to VS Code. Oh, and by the way, this is something else that I've been playing around with this past week is .NET Interactive. Using basically it's like a Jupyter notebook, but for .NET. It's pretty cool. So I'm trying to get this working so that I can use this as a basis for doing talks and that sort of thing. So yeah, so this is an interactive notebook lets you write Markdown and code in the same document, and then you can execute the code in order to demonstrate things, and then you go back to the Markdown. So here I'm putting together a quick description of how you can use different mechanisms to as identity, like here talking about public keys, and then if you put that public key into a record in C#, that then you can compare those records, and they will compare as equal if they have the same public key. So basically introducing people to the idea of a fact as being identified not by some external ID, but instead by its set of fields. So it's like, yeah, it's just like a C# record. So it's not so crazy. So here what I put together is I've defined a couple of facts, an employee and a company, and then we've got the query that gives you back the employees, and then just writing the expression at the end causes the notebook to kind of dump out the expression, the value of it. So actually, at this point, it looks exactly like the Lambda link pad stuff that we were looking at a couple of weeks ago. But yep. So the bonus here is that this works on a Mac as well as on Windows. Works in Visual Studio Code, and I should be able to get a nice visualization instead of just a table out of this. And so I'm investigating how to make that happen right now. But yeah, once I've got that, yes. So the extension that you want is no, not that one. Well, where is it? I just want to have the ones that I've got installed, but it's the project is called .NET Interactive. Yeah, so that's the one. .NET Interactive Notebooks. Yeah. I would say it's. I actually still kind of have a soft place for LinkPad in my heart, but I would say that this is more accessible to a wider audience, and so that's why I think I want to go for it. It's also different in that you can mix the text with the code, whereas LinkPad is just about the code. So it makes it good for having some descriptive stuff around the code that you're trying to demonstrate. So, so yeah, what I've got here, we are hiring both Jane and Bob to Contoso, and I've written the the query in a very just using the extension methods. I can translate this into from fact from employee in facts of type employee, and then put the where on the next line. So where employee dot company equals company. Then select employee. So those two things mean exactly the same thing. In fact, if you take a look at the expression that's generated, it generates this expression, and this is the one that that Jinaga is actually parsing, but you get to write it like this. Yep, exactly. Yes. Every time it sees where, it just says whatever you're feeding into me has to have a .where method. So it could be iQueryable, could be IEnumerable. Whatever it is, I'm just going to call .where. and then let the rest of the compiler run those checks. So so writing it like this, it's a little bit clearer. What I discovered here is that this is the part that you give a name. And so in fact, if I do, rather than show you the employees, I'm going to show you, let's go ahead and take that specification out so that we can say specification dot, and help me out there. Oh well, 2D or pipeline, 2 descriptive. Yeah, sometimes doesn't do a great job of IntelliSense. Okay, run all. Alright, it is having some difficulties. Yeah, for that very last one, yeah, you don't want to have the semicolon so that it knows to evaluate that expression and give you the output. So, I wonder if it's just this, that it doesn't have, let's see, let's go back to, let's go to, where's Jinaga.net? Oh, okay. There it is. Okay, so I'm going to do a .NET test Jinaga test. So that'll make sure that everything is built. Yeah, so now Control Enter, and it should execute. Why are you not executing? I'm not sure why it's not executing. Let me reload. Okay, there we go. Alright, so, that's because I was working on moving stuff over. Okay, well, let's just make this pass for right now. Okay, there we go. Now I can run everything. Alright, so active employee. And so try that. There we go. Alright, now we can see. Okay, so you still there? Okay, cool. Yeah, so here we're seeing the pipeline, and so this is a pipeline starting with a company, and it's got only one path in that pipeline. So the path starts with company, but then it ends with employee. So company has to be somewhere else. It has to already know what that is, and so that's how it knows what type that is. But employee, it's defining right now for the first time. And so that's the type of employee. So starting from company, you follow the successor in the role company until you find an employee. And so that's just a little one-step path. So the the thing that I noticed is that so that path you have to give a name to it right there, so that you can write this kind of a where clause. So the where clause points up; it follows predecessors up in one direction on one side of the equal sign, and then predecessors in another direction on the other side of the equal sign. And so the thing that you give a name has to be that thing right there at the bottom. So that when I first saw that, I was like, oh, that's a neat coincidence that it's already effectively done my optimization for me. That any intermediate steps along the way I wouldn't need to worry about. So, for example, what if I had a clock in this model? So I'll have a fact type corporate quarter. So that is for a given company. We will have a, we'll just say int year and then int quarter. And then we don't hire an employee directly to the company, we hire an employee within a quarter. So, first quarter, we do a new order for Contoso, and that's going to be 2021, comma 1. So now we have hired both Jane and Bob in the first quarter. So now it's not employee.company, it's employee.quarter.company is equal to the company. So now when I take a look at that pipeline, I can see I'm still trying to get from company to employee, but now I have to take an extra step. So I have to, starting from the company, do successor in that role of company, the quarter. So the quarter is pointing to the company with that name. And then a successor along the edge named quarter to the employee. So what this is telling me is I did not have to name the quarter. I never had to say facts of type quarter. But that is also exactly the same reason that I don't need to start an inverse at the quarter. I know that the quarter is not going to be the thing that I just learned about that I now have to tell you about a new employee, because I don't have any employees yet. They're successors. Mm-hmm. Right, exactly. Yep, so you just wait until you see the employee, and then you say, okay, now I can notify the company about the new employee. Mm-hmm. Yes, so let's suppose we have a department. So that's just for the company as a whole. And we'll assume that the department name doesn't change, so we'll use that as the ID. So now if we want to have a query, let's suppose that we've got a specification that will take us from the department. Yeah, actually, this particular example isn't going to work out quite to answer your question, but we'll get there. So I'm starting from the department, and I want to find all of the employees that are available to me. Yeah, so I'm just looking for who can I poach. So those are all of the employees that work for the company that I'm a part of. So so I've got employees are the ones that I'm looking for, and I can say the department.company. So I can look for them. Yeah, I think once we do that, then it's going to show the scenario that you're asking about there. So far, since my starting point and my ending point are we can follow the paths up to a common ancestor, a predecessor, or transitive closure thereof. Above, then we don't need to name anything in between, even though we are kind of zigzagging along the path. So I didn't need to name the department because department is at the peak, but if something was at the trough, then I would have to give it a name in order for it to show up. So if I've got an assignment, exactly, yeah. And so we'll do that so that we can disambiguate. And so now, given a department, if I want to match all of the employees that are assigned to my department, then I have to give an additional name. So I have to say from assignment. So that's going to point back to the department. And now that I've got the assignment, I can say from the employees yeah. Yep. So so now if I run that, I get a pipeline that has two steps in it, or two paths. So one path takes me from the department to the assignment, and so that one is a successor step down to the assignment. And then another one that takes me from the assignment to the employee, and that's a predecessor step along the employee role to that employee. So so I had to name two things, and I got two paths out of it. And so now with this, when I take the inverse, I can notify the department of a new employee when I see an assignment. So that's the fact that an assignment can cause that notification to happen is now kind of revealed by the fact that there's a path that names assignment. Yes. Yes, exactly. Right, yeah, so this is just the forward query. What I can't do is pipeline dot compute inverses, and then let me take the first of these. I think there's just going to be one, but let's make sure. And then let's take a look at the inverse pipeline and output that. So if I do that, now there is an inverse pipeline. So when I first learn of an assignment, then I can find the department that assignment belongs to. So that's the department that needs to learn about the new assignment, the new fact. And so that fact will give it the employee. I think that's the only one. Let me make sure. Nope. There are two inverses. So the second one is when you just learn of an employee. Oh, okay, interesting. Yes. So this is telling me that the optimization is not perfect. This allows more things than the optimization allows. So anyway, what this is saying is that when an employee is hired, so you have a new employee fact, then you can take a look at the assignments for that employee. Problem is, those are successor steps. So at the time the employee is hired, they don't yet have an assignment, then this will never yield any results. So actually this inverse right here is never going to have any effect. So this one could be optimized away. Yep. So so the compute inverses, that is, I started making that work so that I could have the watch, so that it on add and on remove, it notifies you about facts. So yep, that is in progress, I would say. Yeah, not working perfectly. So I think this one I will further refine and optimize this one out. But yeah, I should be able to detect, hey, that first thing is a successor step, so throw that one away. Yeah. Well, I've been thinking about this kind of stuff for a long time. And by the way, this right here, there is a shortcut for this, but it should yield the same pipeline. Let's go ahead and see if it does. So rather than naming employee, just so that I could select it, I could actually just select assignment.employee. Oops. So that should give me the same pipeline. Yes, yeah, it does. So that means it's going to have the same inverses and everything. So I didn't need to use facts of type in order to get the name employee, but because I'm using this dot syntax, I'm accessing a predecessor inside of the select. It says, well, in order to get that, I need to take another predecessor step, so I'll generate a new path within the pipeline. So so there's still a bit more work that I want to do around the sorts of things you could put into the specification. One thing that I want to be able to do is to have mutable properties selected as part of the projection. So I don't know if we talked about this yet, but let's suppose that I've got an employee name. So that is for an employee, I've got the string value for that name, and then since this is the mutable property pattern, I refer to the previous values, the ones that I'm replacing. So I've got employee name array prior. And so if for the specification what I want is the just the names of those employees, not the employee records themselves, then now I do need to say from employee in facts type. Well, actually, no, I don't need to do that yet. Okay, I do need to do employee name for sure in facts type employee name. So now we're the employee name dot employee is equal to the assignment employee. And now I can select the employee name. So that for a given department, now that will list out just the names of all my employees. But what I really want to do is to really have a list of all the employees and have their name as a property of each one of those records. So basically, I want to if I have some sort of a conflict and I've entered an employee name twice, two different names, but neither one knows about the other, then that would be like a concurrent edit of the name. That'll return 2 records for that employee, one for each of those names. And that's not really what I want here. I want to know that those 2 are the same employee. So so what I really want to be able to do is to say the employee is equal to that employee object, and the name is equal to employee name dot value. Now that gets me part of the way there, because now I can I'll be getting back a collection of multiple values of tuples, and each time I've got multiple names for the same employee, I'll just get I'll get 2 tuples. Each one will have the same employee in the first value. What I really want is something that's just unique by employee, and then it has just their name as the value. By the way, I don't think this is going to work yet. Right? Yeah. Yeah, that doesn't quite work yet. This one does. Okay. So yeah, this one does, as long as I don't do the .name at the end of it. So it knows that employee and name are both facts, and it's going to basically give me a pipeline that gives me back employee and employee name, and then I can project that into this structure. But what I really want is give me just the employee, and then for the name, I want to do this part. So I'll do and facts of type employee name, dot where, and then have that clause there. So that way I don't need to do this. And so this I know is not going to produce a pipeline. It's going to give me all sorts of errors. So I just need to figure out how to parse that. But what that will do, so let me go ahead and finish out what I want this to look like. So I could do it like this. So so now this employee is going to be unique. I'm going to get back just one result per employee, or per assignment, really. So yeah, the only way that I can have duplicate employees is if I have duplicate assignments. So this model does allow for an employee to be assigned to a department multiple times, because you've got different assignment dates. So holding that aside, for each employee that I get per assignment, this will give me back a collection of names. So I might support that. Where now what you're getting back out are, here's an employee and the list of names. Or I might decide that all I need for what I'm trying to do right now is first or default. Maybe even order by something that allows me to be confident about which one I'm selecting as first or default. So that's still kind of a work in progress, but going one level deeper and having more queries while you're inside of the projection part. That's one of the next things that I'm thinking through. I'm preparing for a presentation that'll be in September, where I'm thinking about actually using .NET Interactive as the mechanism of that presentation. So yeah, this notebook here that talks about identity. So here I'm talking about identity from the perspective of a database. So I've got a sequence in Postgres, and I'm going to that database in order to get the next number in the sequence. So why do I call that location-specific identity, and what are the problems there? All the way through to no. Oh, okay. Yeah, I was looking for a PowerPoint presentation that that I started putting together in order to kind of reason through it myself, and then I was thinking that maybe I could share that with you as well. So that might be a little bit too deep for like a general user group presentation. So yeah, so I don't know that it'll ever make it to that point, but yeah, that so there I basically I took just my scribblings on the whiteboard and said, well, let's clean this up so that I can think through it. So yeah, I had a graph where I said I have to name certain points within this graph. So anytime I say facts of type something, I have to give it a name. And those names happen to be exactly where I need them to be in order to make sure that I haven't optimized away too many things. So if I can do a whole bunch of dot stuff on each side of the equal sign, the things that I'm passing through as I go along each side of the equal sign are things that I know that I can optimize away. But if it turns out that I have to name it, then there's also a pretty good chance that I have to keep that inside of the pipeline. So we saw an example where there is actually something that I don't have to keep inside of the pipeline when I take the inverse. So yeah, there's still an optimization pass that needs to be done on top of that. But yeah, so far I've been, it started out as like, hey, isn't that an interesting coincidence that the way that you have to describe it in .NET kind of lines up with the way that you have to optimize it, and also kind of lines up with the way that that I had chosen. So let's get back to where we can see some pipeline stuff. It also kind of lines up with the way that I had chosen to express a pipeline. So when starting on this project, I was originally just going to take the pipeline data structure that is outlined in the book. That's just kind of that each step, and it feeds into other steps, and just represent that in code. But then, how do you represent that kind of a fully connected graph in text? So not just fully connected, but I mean over connected. So you should be able to split and join, and so it's not just a tree. It's a full graph. And so when I started thinking about that, I said, well, if I give each of the the places within the graph a name, then I can say, okay, this step takes you from that one to that one. And so just to make things easier on myself, I wanted to take the names that the developer had used inside of this link expression. And so that kind of led me to this point where I'm expressing the pipeline in terms of the things that they have to name. And so it was like, hey, isn't that a coincidence that those are also the things that I need to pay attention to when I'm optimizing an inverse? Yeah, I think that there is a fundamental truth that both of these things are hinting at. And that truth kind of revealed itself when I thought of a different way of thinking about an inverse, and then the things that opens up. So we saw how we could compute an inverse and then turn that into a descriptive string. Right now we're just looking at the descriptive string of the forward pipeline. Well, if you were to, instead of thinking about the pipeline as a set of instructions, you think about the pipeline as just a set of relationships. So now you have, in this pipeline, 3 identifiers: department, assignment, employee. And this statement right here gives you a relationship between department and assignment. So if you were to just reach into your bag of facts and you were to pull out a department of that type and an assignment of that type, and then check this relationship, are they related in this way? You would just get true or false. They are or they are not. So if you've got a department that is a successor, that is a predecessor of the assignment. So you're starting at the department, you take the successor step, and you find the assignment there. If you have that pair of facts, then they are consistent with one another within that relationship. So if this is an assignment to a different department, then they're not consistent with one another. So I started thinking about this not in terms of start at the department, take the successor step, see what assignment you end up with. It's given these two things, are they consistent? So that means that I could ask that question in the opposite direction. I could say, given an assignment, what are all the departments that assignment is consistent with? And so I could write that as a sequence of instructions by basically just reversing department and assignment and then taking this successor and making that predecessor. And in fact, that's exactly what the compute inverses function does. Oh, sounds like I lost you. Okay, there you are. Yeah, it does. Yeah, this is even a completely different machine and everything. Yeah, so you can think of it as the department and the assignment being consistent with one another along this this path, and so you can ask that question either direction. And so taking an inverse is just simply reversing these steps and inverting those steps so that you can execute it in the opposite direction. So start at the assignment and find your way to the department. But that's all that there is to it. That's all that the inverse does. It turns, it's like solving an algebra expression. In algebra you can say, okay, this means, take a number x and then add 2 and then divide by 4, and that's your algorithm for finding y. But you can rewrite that to give you an algorithm given y to find x. So it's exactly the same thing. It doesn't change the meaning of the pipeline, it only changes the sequence of steps, the algorithm. So, but this pipeline has 3 named facts: the department, the assignment, and the employee. So we really have a 3-tuple, a tuple that has 3 facts in it: department, assignment, employee, and the tuples that are allowed are those in which those 3 are all consistent with one another. They're all mutually consistent given these paths. So they're all related to one another in this particular way. So now if you just look at the pipeline in that way, it doesn't matter that you're starting with the department. You could start with the employee. And you can say, okay, given an employee, find all of the department, assignment, employee tuples with this employee in that 3rd column that are all mutually consistent. And that is exactly solving the inverse. That's all that the inverse is. So does that part make some sense? Mm-hmm. Yes. Mm-hmm. Yeah, that's a really good observation. So to make this real, let's say that that an assignment can be revoked. Yes. Exactly. So we'll just say assignment revoked, a particular assignment. So that way an assignment can only be revoked once, but then in order to reassign an employee to the department, you just create a new assignment. So now we are looking for the assignments for that department, but also where there does not exist a yeah. Okay, so not any of those. There we go. Yeah, the type checker finally caught up with my frantic typing. Okay, so so now we compute that pipeline, and we see that okay, we've got a pipeline with 2 steps and 1 condition. So now in this way of thinking, and in this way of expressing the pipeline, the condition is no longer part of a path. So we still just have these 3 named things: the department, the assignment, and the employee. And then we've got not exists starting at the assignment, so that's already part of the outer pipeline's tuple. So that's already a name that appears somewhere out here. And then within here, we define a new name for assignment revoked. And so now we're looking for a tuple that has a relationship with that assignment. And so if that does not exist, then we allow this outer tuple to exist. If that assignment revoked tuple does exist, then that filters out this assignment no matter where it appears. So any department, any employee, that assignment is going to get filtered out. So so yeah, so you made the observation that when we take the inverse, now that's not going to exactly line up with what I was just talking about, where you just took these tuples and you put the value in at some point, because assignment revoked is not part of that 3 tuple. It's not part of the department assignment employee tuple. So let's see. So yeah, I happened to the last one was the correct one. So when I see an assignment revoked, then I'm going to look for the assignment that's consistent with it, and the department that's consistent with it. So with this line of thinking, I should also have the employee that's consistent with that assignment revoked. So there should be one more step. So I think there's still some work that I need to do on the compute inverses in order to make sure that it's got all 3 of those. So the condition has basically disappeared from the inverse. So we're now inside of the sub pipeline, and then we took the inverse of that sub pipeline and found that when an assignment is revoked, it's supposed to remove an assignment. And now, how does that assignment participate within the larger pipeline? And so, have to continue the inverse from there. So yes, you're exactly right that the simple explanation that I gave is incomplete. That you have to take this inverse and then use it inside of this other inverse. And then the line between them disappears when you do that. Let's see. So that's all going to be inside of Jinaga. It's going to be in pipelines. So yeah, there's the inverter. So so one thing that I'm doing with this code base is I'm separating the classes that store, that represent state from the functions that operate on them. So it's taking a little bit more of a functional approach. So inverter is just a bunch of static functions that operate on pipelines and the components thereof, like paths and such. So invert is no longer a method on a pipeline. So, well, I guess technically yes it is, because here's pipeline compute inverse, but it immediately says invert this pipeline, please. But yeah, that allows me to do all sorts of pattern matching stuff, like here where we well, actually, yeah, this one doesn't use a lot of pattern matching. So yeah, I think this inverter is pretty simple to understand. And yeah, I think the thing that made it simpler to understand is the fact that that I changed the data structure from just a sequence of steps to now there's a certain amount of work that you can do within a path. So a path is a very specific thing now. So a path has a start label and a target label, and then it has the predecessor steps and the successor steps. You always go up some number of steps and then come back down some number of steps, and that's the entire path. You can't turn around and start going back up again. And either one of these could be empty, so it could be a path that just goes down or a path that just goes up, but it can't be a path that goes down and then back up. It has to go up and then back down. That way you begin a path at the valley, and you never begin a path at a peak or somewhere along the edge. Yeah, I think this is going to be pretty pretty understandable. There is a little bit of counter to what I just said. There is actually a little bit of work happening inside of the path right here. One of the things that I worked on, I didn't do too much work last week, but this is one of the things that I did do, is that you can execute a path directly on a graph rather than having to go to the store. But that only works if the path only searches the predecessors. So it only searches up within the graph. So the graph contains the transitive closure, and so if you're only doing predecessor type searching, then all the information is already in the graph, and you don't need to do anything asynchronous. So yeah, you will see those methods there. So you can execute steps directly on a graph. But yeah, I think the inverter is going to be pretty easy to understand. And in fact, if you take a look at inverse test, we've got a couple of unit tests for inverses. So by no means a complete suite of tests yet. Mhm. Yep. Yeah, so I will, as you get into that research, I will show you just a couple of reasons that I'm, really excited about this way of thinking about the pipelines. Um, so, so let me go back to looking at the regular forward pipeline. So given this pipeline, I currently have a department as the thing that's coming in. So I can, starting from a department, find all the employees. But there have been several different scenarios that I found myself in where I need two inputs. Like one that occurred inside of the Improving You application, where learners will register for courses. So if you're on the course registration page, you see a list of all the courses that are currently being offered, and you get a different experience whether you have already registered or you haven't. So if you've already registered, then there's a button that allows you to unregister or to see extra details. Whereas if you haven't registered, you get the chance to register. So you really want to have a query that is all the courses available that I have registered for. So you want to have that relationship between the catalog of courses and the learner, the user. So you really want to have a pipeline that starts at two places. So I didn't have that in the JavaScript version. First of all, because pipelines in the JavaScript version are just very linear, but also because I didn't have really a good concept of what it means for a pipeline to start at two different places. But now that I'm thinking about them as tuples of facts that are consistent with one another, I could constrain those tuples to where two of them are filled in, as long as those are actually consistent with one another. Give me the other parts of the tuple that are consistent with those two. So, if this is user and catalog, then all of the courses in that catalog where that course is has a registration with that user. So now those that user, that catalog, that course, and that registration are all consistent with one another, and I constrain it with those two things, and now I just get the ones that you are currently registered for. So that will allow me to now do something like this. So I can now have two different facts that are coming in, and maybe it's also represented here. So I've got a fact of type department and a fact of type user, and now I've got this this pipeline that uses both of those and joins to both of them. So that's pretty exciting. The other exciting thing is that I can have more than one path between two points within the graph. So here I've got actually this is a really good one. So here I've got a path between employee and assignment, and then assignment and department. What if I want to further constrain where the employee quarter dot company is equal to the assignment dot department dot company. So now I am I'm ruling out these weird shapes to the graph that would actually assign an employee from a different company to your department. It's like, no, I don't want those. I really just want employees that are employees of this company and assigned to departments of this company. So those are the only ones that I'm interested in. So this, and this won't work right now, but, let me make sure. Yeah. Oh, okay, that's because of that. There's no way this works yet. Yeah. Yes. Okay, yeah. Yeah, so this gets me to a situation that I haven't implemented anything for yet. But yeah, basically I find that one place where that's not implemented, and I say, oh, well, in this condition, what you're really doing is you are creating just one more path between the employee and the assignment that goes this direction. So employee, quarter company, assignment, department company. And so now I can add paths to the pipeline that only constrain the tuples. They don't add new elements to the tuples. And the employee's already there, the assignment's already there. So it's like adding more equations to a system of equations without adding in any new variables. And so that allows me to put further constraints on it, and then I can basically put extra validation into the pipeline. So this pattern comes up an awful lot in the mutable property pattern. So I'm looking for things that haven't been superseded by another property, but it would be nice to be able to further constrain it. They haven't been superseded by another property of this exact same entity. That's something that I just kind of take for granted, that you're not going to have a property of a different entity that has the wrong thing as the prior. But now this allows me to make that explicit. So yeah, I'm pretty excited about what this opens up, and so I think that's going to be a really good addition. No, it's not. Yeah. In fact, if you take a look at the so yeah, if you take a look at this pipeline execute, that's you're seeing execution of a specification, and even more general one is when we take a look at, oh, that's right, it's in Jinaga.unit test. If we take a look at the memory store, that is an execution of the pipeline against the entire data store. So that's something even more general. And if you take a look at the Jinaga JS, then if we take a look at Postgres, oh, that's the tests. Yeah, we're looking at so yeah, here's the Postgres store. So this generates some SQL right here, SQL from steps, build query. Yeah, so this is really getting into how you turn a specification into something that's executable. So putting together a SQL query from this. Mm-hmm. Yeah, yeah. So this is working on the on the more linear meaning of pipeline, where a pipeline is just a sequence of steps, and a step is a condition, an existential condition, or a property condition. So that was when I had, this doesn't have to be type, but it's always type. So I don't have the general property condition ID anymore. And then these joins in the direction of predecessor or successor. And back, there you go. Along a roll. So yeah, the step idea was a very a very linear idea, and each step could be one of those different things. But now with a pipeline being a sequence of paths, each path takes you from one label to another label, and a path is a very constrained set of steps. It's predecessors followed by successors, and no conditions. And then a pipeline also contains conditions, which apply at a specific label. So it's a much more constrained data type, but really allows for a lot more expression. So yeah, that unfortunately does mean that you can't just translate this code into C# and from Postgres into SQLite. Yeah. Yeah, and that's where you can take a look at Postgres spec, and you can see these are the types of queries that you might expect to get out of it. And so you can kind of try to understand, well, why is that particular pipeline represented by that particular SQL? And in fact, I do get into a little bit of the algorithm for converting from pipelines into SQL in the chapter on SQL databases. All right. Well, I believe it is time for me to get back to my brand new project. So yeah, just starting. Here it is. Yeah, just starting this new project today. So yeah. Yes, indeed. Yeah, this is my first time working with a lot of video. So this is kind of a video streaming application for a mobile device. So yep. Yeah, so I get to use React Native as a for a real project now. So hopefully it has matured since the last time I looked at it. Oh, no, I haven't. Mm. Hmm. Mm-hmm. Yeah. Hmm. Interesting. Okay. Yeah. Hmm. That is a really good use of that concept. Yep. Yep. So if you exactly share this file, it's going to be the same hash, and they say, nope, we already analyzed that picture. We know that one is disallowed. Yeah. Yeah. Very nice. Yeah, I haven't quite decided. Do I want to go earlier in the day? Do I want to change the day? So I think for next meeting we'll go ahead and keep it at the same time, and then I'll just kind of evaluate during this week what's going to be best for this particular client. Yeah. Okay. Yeah, I will do that. Yeah, yeah, I know. That's one of the advantages of, one of the reasons that I might take it earlier so that I could do this before I leave the house. Yeah. All right, Jan. Yes, indeed. All right. Talk to you later. Bye.